In our previous videos, we talked about horizontal and vertical shifts, reflections. Those are rigid transformations because their shape doesn't change. However, today we want to look at stretches and shrinks. Those are non-rigid transformations because their shape does get changed when we perform that transformation. So if you have y is equal to f of x and you put a c out in front of that function, that's going to cause a vertical stretch or shrink. Now, when we talk about transformations, with the three boys in my house, I think of Transformers and I think of cars transforming into robots, right? I also think of Romans 12:2, because Romans 12:2 says, "Don't be conformed to this world, but be transformed by the renewing of your mind." It is so difficult for us to not be conformed to this world. There are so many pressures around us, so much social media and things that we see that tell us what we're supposed to look like and how we're supposed to dress and how we're supposed to act and who we're supposed to be accepted. But Romans 12:2 says, don't be conformed to this world, but instead be transformed. If you're a Christian, you should look as different from this world as that robot does from that car, because we have been transformed. And how do we do that? It says we do it by renewing our mind, by focusing on the things that are really important, by spending time reading God's word, praying, being a part of a student ministry or Young Life or some group where you're going to surround yourself with people that can encourage you and build you up and strengthen you in your faith. So just some encouragement for you today. So for our transformations with the constant out in front that's going to cause the vertical stretch or shrink, if that constant is greater than 1, it's going to be a stretch. If that value is between 0 and 1, you're going to have a vertical shrink. All right, how many of you played with Silly Putty when you were a kid? If not, you're going to need to go buy some. But when you were playing with your Silly Putty, you could flatten it out and you could get the old-timey comics out of a newspaper and you could take your Silly Putty and put it down on Charlie Brown's face. And when you peeled it back up, Charlie Brown's face was on your Silly Putty. It was so cool. And then what did you do, right? You grabbed the Silly Putty top and bottom and you pulled it up and down, and Charlie Brown's face got stretched into like a cone head, right? And then you took your Silly Putty and you smushed it back together again until Charlie Brown got short and squatty and looked like a Cabbage Patch Kid, right? So that's the exact same idea of a vertical stretch and a shrink. When we're going to stretch our graph, it's like we're grabbing this is of course the square root of x, but it's like we're grabbing it right here and we're grabbing it right here and we're pulling it in two separate directions vertically. We're pulling it up and pulling it down and it's stretching it. Or if we're, grabbing it here and pushing our hands together, it's like it's shrinking it. So if we have y is equal to 2 square roots of x, what do you think that's going to do to the graph? Well, that 2, of course, is a vertical stretch, but it's a vertical stretch by a factor of what? Of 2, right? It's going to double it. If you think about it, this is why every one of these y values is going to be double what they were before. So what would this graph look like if it were doubled? Well, it would just go twice as high, right? So maybe up here somewhere. Well, that's our hypothesis, so let's check it. Let's plug in a couple of points and see what we get. So when we plug in 0, we get 0. When we plug in 1, we get 2. And when we plug in 4, we get 4. And so sure enough, if we come up and graph those, yep, exactly what we thought it was going to be. And notice that these y values are exactly double the y values that we have on the original. All right, look at the next one. So for the next one, we have 1/2 out in front. So what's that going to cause? Well, that's going to cause a vertical shrink. And how much do you think it's going to shrink? It's going to be about half the size it was before. So go ahead and sketch what you think that would look like. All right, now let's check by plugging in points to test that hypothesis. I think it's probably going to be about half as high as it was, so maybe running in here. All right, so if we plug in 0, 1, and 4, sure enough, those y values are half of what we got. And if we graph it, then that's what our vertical shrink of our graph looks like. All right, so let's see if we can put it all together. So we had already been looking at horizontal, vertical shifts, and reflections, and we said the order that we needed to follow was horizontal shift, then reflect, then vertical shift. So let's start with that. Do you have a horizontal shift? Well, yes, because any value subtracted from x is going to be a horizontal shift, and 1 is being subtracted from x, so I'm going to have a horizontal shift of +1. So I'm going to take my normal square root function that would be here. I'm going to shift it over a +1 and draw the exact same thing. All right, then do you have a reflection? Yes, because you now have a negative out in front of the entire function. That's a reflection in the x-axis. So let's take our green graph and let's reflect it in the x-axis. All right, then do you have a vertical shift? Well, yes. This +3 is going to cause a vertical shift of a +3. So we're going to take that red graph that we had just drawn and we're going to go up 1, 2, 3, and then we're going to draw the exact same thing. All right, and so now that last component that we just learned, do you have a stretch or shrink? Well, yes, this 2 out in front is going to be a stretch by a factor of 2. So we're going to take that blue graph. It's going to start at the exact same spot, but we're going to stretch it so that it goes twice as high as it was going before. And so that would be our final graph with that stretch by a factor of 2.